Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving generate parentheses. I will go over two ways to solve this problem, but we'll only go over the coding for the optimal solution. If you are only interested in the optimal solution, then feel free to skip to the timestamp. So the problem states that we are given n pairs of parentheses, and we want to write a function to generate all combinations of well-formed parentheses. And well-formed just means that in a combination, the closing parentheses would always come after their matching opening parentheses at some point, and that would make a valid combination. And then we want to put out all the combinations that are valid. So if n is equal to 3, meaning we have 3 opening and closing parentheses, these would be all the valid outputs. And if n is equal to 1 for this example, then this would be the only valid output. So how can we solve this problem? One way that we can solve this problem is that we can generate all the possible outcomes. So let's say if n is equal to 2 for this example, then in the first iteration we will have an opening parentheses and a closing parentheses, and these will be the two options. And as we continue on, all the arrow ups will add an opening parentheses and all the arrow downs would add a closing parentheses. And as we see, if we keep iterating, these will be all the possible outcomes, and then we have to check which ones are valid, which only these two are valid, and that would be the result. But this time complexity of this problem would take O of 2 to the 2n times n, because there will be 2n outputs because of the closing and opening parentheses, so you have to multiply by 2 to n, and it will be 2 to the power of 2n because for each iteration we're generating double that number of outputs, so that's why it will be 2 to 2n, and then we have to multiply by n because it will take about n time to check if the string is valid or not. So there's actually a more efficient way to solve this problem, and we'll go over that way right now. So a better way to solve this problem is we can use backtracking. So basically, instead of checking for the valid parentheses at the very end, we should check it at each iteration. So as we can see, if we put a closing parentheses before any opening parentheses, it doesn't really matter what we add to the string afterwards. So all of this could be skipped through. And if we put an opening one, then these two are both valid. And as we see later on, if there's more closing parentheses than opening parentheses, then it can all be skipped. Or if the number of opening parentheses is greater than n, then we can also skip the rest of these iterations that are not necessary. So basically how the algorithm will work is we will first add opening parentheses as long as the number of opening parentheses is less than n, and once it reaches n, then we will start adding closing parentheses as long as the number of closing parentheses is also less than n. And once that also reaches n, then we will continue to pop the closing parentheses until it comes to a new opening parentheses, and then we will pop the opening parentheses and add a closing parentheses and continue the algorithm. So if we look at this example, we will start here, add an opening, equal to 2, so we add a close, and then we add a close. And now this is one of the valid outputs, so we will add this to the output. And now we will pop a closing parentheses, pop another closing parentheses, and now we come to an opening parentheses. So we pop this one, and then now we add a closing parentheses, and we continue the algorithm. So now we add an opening is equal to 2, and then now we add a closing parentheses, and now the number of closing parentheses is also equal to 2. So then we also add this to the output. So for this example, the output would just be these two, which comes from here and here. These would be the only valid parentheses when n is equal to 2. And the time complexity would be O of 4 to the n divided by rad n, which I'll explain in a second. And the space complexity would be O of n, where n is the number of pairs of parentheses, because the backtracking algorithm can take up to n recursive calls. So the reason for the time complexity is because this problem actually follows the pattern of a Catalan number. If you don't know what that is, feel free to look it up. But basically, this is the formula for a Catalan number. And we can first rewrite the formula to this, because n to the 3 over 2 is basically n times the square root of n. And now that we have rewritten this, we need to multiply it by 2n, because there is 2n pairs of parentheses because of there's opening and closing parentheses. So we need to multiply by 2 to the n. So if we multiply 2n by this is what we have. And then if we keep simplifying it, these two n's cancel out, which it will look like this. And then after we simplify it to this, we can remove the 2 over rad pi because these are constants and they are not necessary. So now we simplify to the time complexity of 4 to the n divided by the square root of n. So now let's get to the coding part. So first we'll initiate an empty stack and we'll initialize the resulting array as well. Now we'll write the recursive function. We'll call it backtrack, and inside the parentheses we'll have open and closed. So if the number of opening parentheses and closing parentheses is equal to n, then we will append whatever string we have to the resulting array. So join stack, and then we return. Now if the number of opening parentheses is less than n, then we will append to stack. So stack.append opening parentheses, and then we'll make our recursive call, but the number of opening parentheses should go up by 1. And after the recursive call, we will have to pop from the stack. And now if the number of closed is less than the number of opened, then we will add closing parentheses to the stack. So stack.append the closing parentheses. And after appending, we can make the recursive call. But we need to, for the parameters, we need to increase the number of closed by 1. And after the recursive call, we will have to pop from the stack. And that would be our backtrack function. So to start the function call, we will do backtrack of 0 opening parentheses and 0 closed parentheses, and then we will return result. Let's see if it works. Okay, perfect. I hope you guys find this helpful. If you have any questions or comments, feel free to leave it down in the comment section, and I hope to see you all again soon.